Our next task is to measure the period of a pendulum. Now, to do that, we've given you a simple stopwatch. But what we really need to know is not what the time is, but how good you are at using a stopwatch. We need to work out what the delta t is, what the uncertainty in your time measurement is. Now, a difficulty with this is that you have a reaction time of about 0.2 of a second. Now, that's not a real issue because this is a predictable thing we're trying to measure. We're looking at the start of a set of periods and then the end. Both of those things can be predicted. So that 0.2 second delay cancels out at the start compared to the end. What we need to get an estimate of is what is the variability of your reaction time. And the way we're going to do it is this. We have a simple wall clock. This wall clock is good to plus or minus 1 second a day. Now there's 86,400 seconds in a day, so over a 10-second period, that's good to better than 0.0002 of a second. Better than that. Much better than the stopwatch, which is only to 0.01 of a second. So I'm going to time a 10-second period, and here's another hint. Give yourself a little countdown so that you start at 0. So I'll start when the second hand gets at the 12 o'clock section, and we'll go 4, 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I measured 9.91 seconds. That's 0.09 of a second too fast. In other words, my uncertainty in timing in this particular case is 0.09 of a second. I've done this before and got a reading of 10.09. I have read 0.09 too big. And so it seems that the uncertainty in my reading is about 0.09 of a second. I recommend you do this about 10 times so you get a good idea of how good you are at measuring time with a stopwatch.